Okay. So first of all, please allow me to express my thankfulness to Nine, who provide this very good platform for us to meet virtually due to this COVID-19 pandemic. And also thanks for your kind introduction. It's really honored to join this interesting seminar. So the topic I will share today is about the long-term effect of air pollution on human cognition, evidence from China. This is journal work from my PhD student, Lanlin Ding, also from Xi'an Jiaotong University, and also Mao Yongfan from Ball State University in the US. So is my voice is loud enough?
Yes.
Okay, good. Then we continue. So this is our today's journey. So now let's go to the introduction part. So perhaps as you know, the air pollution, especially this particulate matter air pollution, is a global issue, especially in developing countries like China. As you can see here, this figure 1 shows this global situation in the year of 2016. You can see China, India, some African countries, these concentrations quite high. Due to this high concentrations, it leads to quite a large number of deaths, especially in China. As you can see, the dark red means a higher number of deaths due to outdoor air pollution, especially PM particulate matters. So we generally see air pollution is the biggest threat to global health. We focus on how PM 2.5 affect human cognition. So why we focus on cognition? Because cognitive deficit is a core element of mental health conditions, which is an integral part of health and well-being. The World Health Assembly has declared a global accepted principle: no health without mental health. So globally, approximately 50 million people have dementia. The majority of them, are residing in low and middle income countries. There is also one recent study showing that during the period of 2015 to 2060, the number of older adults aged 65 plus in China is projected to increase, which the number with cognitive impairment is projected to increase more than fourfold. This cognitive problem will also result in a heavy economic burden. So why we also focus on PM 2.5? Because PM 2.5 poses the greatest risk to health. Because relative to other pollutants, it is much easier to get into our blood, brain, and also perhaps as recently the PM 2.5 has declined. However, the absolute level of long term at the long run, still very high. And also, some studies found that the majority of the population still live in area exceeding this least stringent WHO air quality, this target, 35 μg per cubic meter. So indicating that ambient, this PM pollution remains a major concern to health in China. The third point is that Chinese air pollution data are very limited. Satellite drive this high solution PM 2.5 concentrations cover the whole country, also provide a unique opportunity to study this topic. So if we go over, those existing studies, actually there are several work, have estimated the long-term exposure to air pollution on mortality and life expectancy in China, like Chen in 2013, Eberstein in 2017. However, economic study on long-term effect of air pollution on health outcomes other than mortality or life expectancy in China is quite limited. Recently, there are quite few studies like, Zhang 2018 published in PNAS, a recent paper by Lai and his co-authors published in AJAE. There are some limitations for those existing studies. Most studies focus on association rather than causality. The second limitation lands at the linkage between concurrent pollution and cognitive performance. So considering this background, we try to answer two research questions. First, what are the impact of the White River policy on PM 2.5 concentrations and also cognition? Second, what is the impact of long-term exposure to PM 2.5 on human cognition? So we try to extend the existing literature in 4 ways. First, our study could be one of the first evidence for this long-term effect of air pollution on cognition. Second, we provide some evidence that substantial long-run losses in cognition among survivors of air pollution. We also extend the evidence for developing countries. Like China, as I just mentioned at the beginning, generally the average level of this PM 2.5 is super high, far higher than those in developed countries. Finally, we also later, as you can see, we also show some interesting policy implications, like when we do some heterogeneous analysis, we find that females, the older and the low educated are more vulnerable. And also we show that environmental pollution actually also serves as an important contributor to health inequalities. Now I just give you an overview of our key findings. So we first found that at the boundary of White River line, PM 2.5 increased by 22.5 μg per cubic meter. It is equivalent to 1.4 standard deviation. And also raise the overall cognition score, decrease the overall cognition score by 3.1 points, equivalent to 2.2 SDs. We also found that the long-term exposure to an additional 10 μg per cubic meter PM 2.5 decreased the overall cognitive ability of middle-aged and old Chinese by 0.7 SD. Such effects also, accumulate over time. It means, if you are supposed to longer, the exposure of this air pollution, you suffer larger losses of cognition. We also found, females, older and low educated are vulnerable groups. For potential mechanisms, we confirm that PM 2.5 negatively affect a series of cognitive related health conditions such as chronic cardiorespiratory disease and psychological problems like depression and also obesity, diabetes. Finally, we do a back of envelope cost benefit analysis. Our estimate shows that one ST increase in PM 2.5 is linked to an annual economic cost of 23.9 billion US dollars in terms of additional medical expenditures on mental illness. If we reduce the PM 2.5 level to the WHO standard, this would save roughly 34.7 billion US dollars annually. This could be a lower bound estimate. Later, I will share more information with you. So, we Chinese may be quite familiar with this, Huai River policy. I guess some audience may also not familiar with this. So regarding this, China's winter heating system, I just give you a brief introduction. So this winter heating system, provided to this residential and also office buildings by government or by state-owned enterprise for free or heavily subsidized. So due to budget limitation, this system only exists to the north of this Huai River Qingling Mountain. This policy, operates during winter, generally, from the middle of November to the next March, with a little, variation across different provinces. So it still, affect current, pollution levels through its impact on this coal-based, heating infrastructure. Winter heating, has been and also still largely non-exist in southern China. So this figure just shows that this boiler, this heating system, because it means subsidized coal is burned to heat water, often in this boiled host, in or near a residential building. This the combustion of this coal emit high level of soot and also this pollutants such as PM 2.5. Now let's go to the second part, methods and data. So this figure 3 shows the geographical distribution of all Chinese prefecture level cities, and also those cities included in CHARS data. Later, I will give you more details about this data set. So this this dark line denotes this Huai River Qingling line, right? And this light green this area, small area, denotes those cities included in the CHARS data. So because as you can imagine, it is impossible for us to obtain, this, PM 2.5 level or this, latitude information at the individual level. So later, all our analysis is based at the prefecture city level. Now I will give you a brief introduction about our method. So we use this traditional method called the regression discontinuity design. So in our case, we use this non-parametric estimation, specifically local linear regression. So here, this if you see this ugly guy, this tall, is 2 parts, one part minus another part, right? So it means if we go back to this finger, we want to use this method to show, whether this Huai River policy along this Huai River line will lead to, a difference in PM 2.5 between north and south. Does this, difference in PM 2.5 concentrations will affect cognition? This is, the essence of this method. So here, the RD design, as I just mentioned just now, this Huai River policy actually, provides free or heavily subsidized coal for this indoor heating to the north of the river, but no subsidies to the south. So in your case, the assignment variable, or we call the running variable, is the latitude of each prefecture level city in charts, which cannot manipulate it. This is the most key assumption for this method. So on the left side of this equation, yi in our case could be the PM 2.5, or could be the cognition outcomes, or even could be the cognition related health outcomes. Yeah, because for this mechanism analysis. Here, L bar means the latitude degrees along which the white river lines. Capital Li means the latitude degrees of location I. For this non-parametric method, I think the key point is how to choose the optimal band weathers and also the kernel function. Why we choose this non-parametric local linear regression? At least 3 reasons. One, because it requires no assumption on functional form between the running variable and the outcome variable. It is also less sensitive to the observations away from discontinuity. Finally, this method is the band weathers selected as a function of the data. So it is data driven. In our case, as I just mentioned, this selecting the band weathers is very important, optimal band weather. So we use this MSE optimal. It means allow different band weathers above and below the White River. So we call the MSE OPT for our main analysis. We also introduced another band weathers called the MSE MED. It means the media. So the media of 3 different these selectors. For our main analysis, we use a triangle kernel function. We use another this weighting function, a penny curve as a robust check. When identifying the long run impact of units of PM 2.5 on cognition, we use this fuzzy RD because in this case you can imagine, regardless of the north or south, both areas may suffer from this air pollution, but with different levels. So this is not a 1-0 dummy, right? So there is a difference. So this method helps us to identify this. When it comes to the data, especially for cognition, our data are based on these charts. We call the China Health and Retirement Longitudinal Survey. I think some of you are quite familiar with this data set. It is sister data set for the HRS in the US, ELSA in the England, and share in Europe. Especially for cognition, we focus on 3 measures. One is mental intelligence. So we count each correct answers, like naming the date, year, day, or season, and also the day of the week. Rejoining a formally show photo and doing a series 7 subtraction from 100. So we sum this all those correct answers. This measure is 12-point scale, ranging from 0 to 11. Another measure is episodic memory. It is also a summed measure, ranging from 0 to 10. The third measure is called the total cognitive score. It is actually a sum of the first 2 measures. As I just mentioned before, because we focus on the prefecture city level, so we aggregate this individual level data to a city level. Now let's go to this long-term exposure to PM 2.5. be careful. Generally, we have two sources for this long-term air pollution information. One is, this grounded, station air information. Another is this satellite base. Because the problem in China is that, those grounded, based information, this air pollution, the availability is quite short. It means, just recently we have such information. And also, another problem for this, ground level, ground level station, is that, it may suffer from, this we call the human manipulation. So we prefer use this satellite-based data set. For this satellite-based data set, we also have different sources. Then, we compare different sources. Then we find that, pre-2003 period, there are huge differences. Just from 2003, the accuracy and also the reliability of this data set becomes, stable. This is the reason we start, this long-term exposure from 2003 to, 2015. So we take the average of the PM 2.5 of each city and all city district for each year. So our long-term air pollution exposure was measured by the average PM 2.5 for all subsequent years from 2003. In our RD analysis, we also introduce weather and also other control variables, like city level GDP per capita and also social demographic and health behavior information. Once again, also at the city level. Now I will show you some basic results. So this figure shows us, the PM 2.5 on the distance from the Huai River line. This vertical dark line at 0 means this Huai River line. And those dots means this different cities. Okay? And on the left side is the south. The cities in the south part, and on the right side is the north part. So as you can see, there is a clear and significant discontinuity. There is a jump. It means compared to the source, due to this Huai River policy, there is a higher PM 2.5 level for those, northern cities, especially along this Huai River line. It is around, 22 μg per cubic meter, equivalent to 1.4 SD. Interestingly, we also found that, there are consistent declines in all our three measures of cognition. Manners 2.1 points for mental intelligence, manners 1.2 for episodic memory, and also manners 3.1 for total cognition score. Those two figures, provide the first evidence of, this cognition decline due to the PM 2.5 concentrations increase, which is attributable to this Huai River policy. For this RD approach, it is very important to check unobserved factors are smooth at the threshold at this Huai River line, but we cannot test this, key assumption directly. So alternatively, we check whether all our controls are smooth at this threshold. That means the Huai River line. So if we take a quick look at the column 4, we can see between the source and the nose, we generally observe similar, weather conditions at this Huai River boundary, right? Also, case for social demographics and also health behaviors. Yeah, we observe no significant differences between north and south. It is good. This table 3 shows our main results. We show the estimates from the fuzzy RD and also the OS, traditional this correlational, analysis in economics. We use OS as a comparison. So as you can see, we have 6 columns. For all the columns, we do not introduce any controls. For even columns, we add, this demographic, weather, health, behavior controls, right? So consistently, we can see for the fuzzy RD, one additional 10 μg per cubic meter PM2.5 concentration will decline mental intelligence by 0.7, episodic memory by 0.2, and overall cognitive ability by 0.7. Interestingly, if we take a relative comparison between the column 2 and also columns 2 and 6, we find that overall the magnitudes are much larger in the fuzzy RD estimation compared to the OS. It means if you just use this correlational analysis, it generally suffer from underestimation of this effect of PM2.5. This is very important. We also make some comparisons with those recent studies in China. When compared with Zhang study in 2018 and also LIES, we find much larger effects of PM2.5 on cognition. Why? I think at least 2 key reasons. One, because we focus a much longer period from 2003 to 2015. Zhang focused on 5 years. LIES focused on 7 years. So because this is the reason we observe the larger this effects of PM2.5. The second reason is that as in Zhang study they use APR, it means air pollution index. This index is based on 6 major pollutants. And some studies has shown that the APR mainly reflects the PM10 concentrations. Compared with PM10, PM2.5 is much easier to enter our brains, blood. So this is the second reason. Formerly, we use a panel data. Now we rerun this RD estimation by wave. So interestingly, as you can see this finger 6ABC, we find that this negative effects becomes larger. If those survivors suffer longer period of exposure to PM2.5. This is very interesting finding. We also do some robust checks. We use alternative canal function, as I just said, use this Epanic curve. And also to consider this seasonality effect on our results, we also restrict interview months from June to October. Then we rerun the estimates. We also use this residue method to control covariance. Another big challenge for this study, for this topic is we call the residential sorting. It means if I live in this highly polluted area, I can move to another area, right, with good air quality. So to take this point into account, this is the reason why we use charts, because charts generally focus on old adults. So they generally this live in the same city for quite a long time. So this is good for us. Even in our case, we check this migration rate. It is super low in our case. Even this, We also drop, the respondents, who live in the city for less than 5 years. Why 5 years? Because, we focus on trials 2011 to 2015. Yeah. We also do some, fake White River line. It means, we move this White River line up and down by 1.5, 2.5, 3.5 degrees. So for heterogeneous, generally, our key results remain there. Now let's go to this heterogeneity analysis. Then, we check, these differences in this exposure to PM2.5. So we check two aspects. One is, we check the different waves I just showed you before. Another, we check this whether, such effect we different between older or younger, ones. In our case, we use 60 for males and 55 for females. Why we use those two thresholds? Because some existing studies show that retirement is a very important element for cognition. So given that, we use those two thresholds. We also do this gender-specific analysis. We also check, whether results are different, by different educational background, by various income levels. Generally, find that the older females and also the low-educated suffer larger losses of in cognition due to PM2.5. So those heterogeneity analyses may highlight that air pollution has unequal impacts on cognition among different social demographic groups. Now let's go to mechanisms. So in this table 5 shows the results how PM2.5 affect cognition-related health indicators. We split, based on existing literature, we split those health outcomes into 3 groups. Panel A, cardiorespiratory disease. Panel B, depression and depressive related symptoms. Finally, physical conditions related to cognitive ability. So we also, if we take a quick look at, columns 3 and 4, for all those, cognition-related health outcomes, we consistently find that one additional 10 mg per cubic meter in PM2.5 concentrations will increase the levels of chronic disease proportions, increase the likelihood of suffering from severe depression symptoms. I do not, name all those variables. And also we can see, PM2.5 will increase the probability of suffering from central obesity and also diabetes. So in particular for, these severe depressive symptoms, especially for columns 3 and 4, we can see one additional PM2.5 concentration will increase the probability of suffering from severe depression by 7.8%, and also 7% for another, because here we use 2 different, these kernel functions. Yeah. Then, we do a back of envelope analysis for cost benefit related to this, PM2.5 on cognition. So as I just mentioned actually in the previous slide, 1 10 mg per cubic meter increase in PM2.5 concentrations leads to 7.4% percentage increase in the probability of having severe depression symptoms. So then we can calculate the long-term PM 2.5 concentrations from 2003 to 2015 and compare it with the WHO safe annual PM 2.5 level. Then the existing PM 2.5 in China will make 103 million adults aged 55 plus suffer from severe depression. If we take a look at the Xu's study, they found that the annual cost of mental illness in China is around $3,665 in 2013. It is equivalent to around $4,100 inflated to 2020. So if all patients were treated, then the annual cost would be approximately $422.6 billion per year. However, the rate of seeking medical treatment for patients with mental illness in China is quite low, around 8.2%. If we take this percent into account, reducing PM 2.5 to the WHO standard would save roughly $34.7 billion medical expenditures on mental illness. But be careful, this is a lower bound. Why? Because we only focus on severe depression, which is just one form of mental health problems. Yeah, we also do not take indirect costs into account. We also do not take intangible costs into account. So it should be taken as a lower bound estimation. So it means the actual cost should be much higher. Our estimates also show that the annual cost of 1 SD increase in PM 2.5, it means 16.2 μg per cubic meter. So it will lead to around $24 billion in terms of additional mental expenditures on mental illness among middle-aged and old adults in China. So to summarize, we found that long-term exposure to air pollution significantly impairs cognition among middle-aged and old Chinese. Such effects become larger as the length of exposure increase. We also found females, old people, and the low educated suffer more losses in cognition. Finally, we show that long-term exposure to air pollution leads to a series of cognition-related health symptoms, including cardiorespiratory disease, severe depression, obesity, and diabetes. Our results may provide some useful policy implications. First, it means the government should retire the coal-fired heating system, replace coal with cleaner energy resources, and also increase investment in developing this fracturing technology. Second, we're doing some these interventions or programs. We should focus on those vulnerable groups, especially females and older, and also promote this universal access to education. Finally, as you know, due to this rapid aging challenge, our government now try to increase the retirement age. But wait, our results also maybe have some implications for this policy. Why? Because if we observe negative impact of air pollution on cognition, it could also lead to deterioration of human capital and lower labor productivity. this could be the last slide for my talk. So I have to confess that, our study is not without limitations. First, as we know, this RD design is a local estimator, very local estimator. Second, we only focus on PM 2.5, which is just one dimension of this outdoor air pollution, at a prefecture city level. We do not, take ambient noise and also indoor air pollution into account. So considering this point, this could be one interesting, research avenue in future. As I just mentioned before, since our study confirms the long-run damaging effect of air pollution on cognition, it raises the possibility that it damages, the development of human capital and also labor productivity. So this could be another, very interesting and also important future research direction. Okay, I think it's time for me to stop here. Thank you so much for your kind attention, and also any of your comments, suggestions are highly welcome. And also, yeah, if also very interested in this topic, our discussion paper version is also available in SSR platform.